All right, hello everyone, and let me go from the official start of my my slide deck. So, my name is Michael Yuan, and I'm the maintainer of the WasmEdge project, which is a CNCF sandbox project. So I have been involved in Wasm since 2018, 2019, that time frame. So WasmEdge was started at that time. And a lot of people ask, what's the killer application of Wasm? I think people still ask this during this conference. That's when people go on stage and say, Wasm. People say, other than Rust can compile to Wasm, what are the use cases? That's so browser maybe, blockchain definitely. There's lots of first-tier blockchains that are implement using Wasm to run smart contracts. But I'm not going to talk about those because those are, I would say pre-2023 Wasm use cases. Coming into 2024, I think the largest, by far, the most significant Wasm use cases that we have seen is to run large language models, to act as the JVM for GPUs. Okay, so write once, run anywhere, but not just for CPUs, for GPUs. Okay, so that also allows programming language like Rust to enter into this space, and compete against things like Python. So, that'd be the focus of my talk. This talk would be very loaded with, demos. So we have 3 demos, and if you're interested, all the demo script is on GitHub. So if you can, if you're interested, you can just scan the barcode and see. We have demos that we did in other conferences, like we did in KubeCon Paris last year, early this year, and WasmIO as well. So you can see how those demos has evolved over time. And so without saying other things, let's get straight into a demo. Let's see how the whole thing works. So if you go, let's see. If you go to the demo script, the quick start, the very first thing is a one-line command, where what I'm gonna do is that I'm gonna do that on this machine. So this is my local MacBook. If I run this script, it's gonna download this script from the internet and then ask me to go through several steps. Although you don't have to do it interactively, you can actually use it as a one-line command. So first, it's gonna tell me what it's gonna do. It's gonna download a large language model. It's gonna download the application server written in Wasm, and then it's gonna start on my local machine, on this small 16 gigabytes M1 Mac machine that I bought a couple years ago when I didn't know better. When people ask me how much memory I'm gonna use, I say 16 gigabytes would be more than enough for web browsing. But now I really regret that. Now I have a 200 gigabytes memory Mac Studio sitting on my office desktop, just doing AI inference. But that's a long story. So the first is asked to install WasmEdge. WasmEdge is about 10 gigabytes since I already have installed, so I would just skip it. And the second, it asks you, which large language model would you prefer to run in this session? We're gonna talk about that later in the talk. There's actually over 10,000 different fine-tuned large language models that you can use on Hugging Face. We support all of them. But here we just have the 15 of the ones that we like most or the most popular. So I'm going to choose number 3, the newly released Llama 3 8B model. And it would ask whether you want to chat with it on the command line or you want to chat with the API server. I'm going to say the API server. So that's it. Let's start the API server. It's going to download the API server, and it's going to show me the command to start it. If I say yes, it's going to load the API server and start it on my local machine. What I'm gonna do at this point is that I'm gonna open up the link, I'm gonna turn off my Wi-Fi so that you can be absolutely sure that I'm not cheating to use some other OpenAI or some other application servers, right? So the first question I'm gonna ask is, where is Estes Park? Where are we? And you can see it takes some time to generate the first answer because it needs to load the entire model, which is 5 gigabytes, into memory, and then it starts to generate the answer. So you see a town in Colorado is located at the entrance to the Rocky Mountain National Park. What is its elevation? So because I heard there's the altitude is high, so I actually flew in from sea level, so I may get maybe I'll get sick. So it says, it's 2 kilometers above sea level, so maybe it's okay. So can I take some medicine to prevent altitude sickness? Okay. It even give out medical advice. So it's the medicine, blah, blah, blah. It's actually pretty good. If you search the internet, it's actually the medicine that Google recommends, So, but then again, I have no Google. This entire thing, what Facebook deemed as the compact version of the human knowledge is all on my machine. It's fairly low-end MacBook, right? And as you can see, it runs at pretty respectable speed, So it certainly, when it gets running, let's see how fast it runs. You can see it in the log here. So it generates tokens, 24 tokens per second. 24 tokens per second is, if I speak like this, is about 5 to 6 tokens per second. So 24 tokens per second is a lot faster than I can speak. Okay, so so that's that's what the large language model on your own machine. So if you don't, I know this is late in the afternoon, and if you remember anything, one single thing from this talk, is that you can go home to your room and try out this and have a large language model, the latest large language model running on your own computer, right? It could be Linux, it could be Mac, it could be Windows. It runs on all of them. And so now I'm gonna stop this, clean this, and I'm gonna Control-C to get out of my Wasm application and turn on my Wi-Fi again so that I can get back to my presentation. All right, so I think so. Okay, so here's, of course, the question people ask is, what you have shown can all be done by OpenAI, I just need the internet, right? So why not OpenAI? There are actually some good reasons. I think by sitting here, most of you already knew those reasons. I think the primary problem is that it's one size fits all in every aspect. So even if you ask it a very simple question, it has to run the entire large model with trillions of parameters to answer you, where is the capital of Japan, for instance. It come up with the answer Tokyo, right? And so something that can be done with much smaller model. And it lacks privacy and control because it has to be tuned and aligned to the most mainstream and least offensive value system that we could possibly have, right? So by using, in my company, we use OpenAI a lot. We use OpenAI to do code reviews and things like that. And we increasingly find issues that it refuses to answer. So for instance, it refused to answer security potentials in a piece of code because it says a hacker might misuse that information and things like that. So there are lots of reasons you don't want to use OpenAI. You want a capable large language model that's running directly on your computer like I just shown, right? So then a better question is that, why don't you just use things like Ollama, or there are a bunch of tools out there, that's LLM Studio, for instance, that can allow you to download a large language model and run it as an API server on your machine, right? So I actually have a better answer, but just for this particular question, there are some compelling reasons why you want to use WebAssembly. The product, the open source project, we call it LambdaConf, but underneath it, it's a WebAssembly runtime. Why do we want to use WebAssembly to do all this? The first is that it's very lightweight and fast. So the entire runtime plus the application is less than 30 megabytes. If you look at the Docker image of any of the above mentioned product, it's in the hundreds megabytes or even in gigabytes, right? And it's very easy to install and run. As you can see, I just run a bash script. It never asked me my root password. It never did sudo, never installed any daemon, never installed anything that I don't already knew, right? So it's very easy to install because it just needs a Wasm runtime. The same Wasm runtime, well, I wouldn't say the same, a similar Wasm runtime that you already have in your browser that runs to run that on your computer. And it can be managed and orchestrated directly by container tools and Kubernetes. That's a very deep topic that I wouldn't go in depth here, but suffice to say that we'll have a joint presentation with Docker next month at the AI Dev Conference to talk about how Docker manages those. And we already have integration with different Linux distributions to allow Kubernetes to manage LambdaConf applications by using Wasm like the outside container, not the Docker, not the Linux container as the outside container, right? It supports a wide range of LLMs, like I mentioned, which I'm going to show later. It also supports a wide range of devices and drivers because Wasm acts as an insulation layer that in between the hardware and the software. So we can not only do popular things like Llama.cpp, we can also do, for instance, NVIDIA has something called the TensorRT. That's TensorRT LLM, where you can use a new driver other than the regular CUDA driver to run LLMs. Intel has a new, well, I wouldn't say new, but advanced framework. It's called Intel Transformer Framework, which claims on new generation of Intel chips, if the model is running on CPU, it's gonna get 40 times, not 40%, 40 times more performance out of the CPU. By having the Wasm sitting in between the hardware and the software application, we will be able to take advantage of all those new frameworks and without changing any of the code that people write, right? So now that leads to my second demo. I want to show you the Wasm application that we have is truly portable. So let me go back to my terminal. And so for here, I'll cheat a little. So I have already opened I logged into a machine on Azure because I turned off the Wi-Fi, so it's logged me out. And if you see here, there's I pre-download a large language model and pre-download a bunch of HTML files. That's sitting here, but there's no application, right? There's no application that actually provides the API server I've just shown. So what I want to do is I take one of the commands that I have if you see this is just the SCP command. This is just copy, right? There's no changing the code. There's no recompiling. But remember, this Wasm application, I just ran it on my Mac. It's the Apple CPU is a Metal framework. Everything on the Mac is different than the NVIDIA machine that's in the cloud. The NVIDIA machine is Linux. It has the NVIDIA GPU. It has CUDA. So everything, the underlying from the driver to the hardware to operating system are all different. So if I list here, now you can see that I have a new file that is directly copied over from my Mac to the NVIDIA machine. Now I'm going to run it. The command, I cheated, so the command to run it is well, I should, I think it's here. No, it's not here, sorry. It's in my workshop documents. It's this one, okay? Yeah. So now I run it on the back end. So, on this NVIDIA machine, I started the same application server. So if this machine has a port 8080 exposed to the internet, I would be able to access it. But since it's on the cloud machine and it's locked down, so what I would do is that I would use it as an API server. And let me copy and paste the API command here. So if you can see, this API command is a curl command that goes to localhost 8080, which is on this machine, right? And it uses the OpenAI format to say for the row of user content, where is Estes Park, right? So if I do this, it's gonna think. Now it come back much faster. You see, that shows NVIDIA is faster than Mac, right? People buy NVIDIA machine for good reasons. As you can see, it gives the OpenAI style response to Estes Park is a town located in Colorado, United States, right? I can keep on going and ask it more questions. But this shows you the same application that runs on the Mac now runs on the NVIDIA machine, right? So let me go back to my presentation. So. Oh, sorry. I think we're here. So the portable machine. So the portability of the Wasm application in this case actually gives a very strong possibility for it to be used directly as a developer platform. So when we talk about large language model developer platform, people's idea, I think, is mostly I have an API server, like I demonstrated, on the back end that speaks the OpenAI language. And then I have LangChain, Llama Index, DeFi, COS, a gazillion of what we call large language orchestration framework or large language model middleware that sit in front of that, right? So that setup is okay, but for every single production-ready LLM applications that I have seen, none of them use this stack to go to production. Okay, so people that we work with, that's in UC Berkeley, in all kinds of places, they use LangChain and Llama Index to experiment, to find out what's the right combination of algorithms and databases that works best for their application, and then they re-implement that. They do that for very good reason. If you look at LangChain, the public interface has over 3,000 functions. Okay, so their key value really is that whenever there's a paper published on arXiv about a new document search algorithm, it's going to be available in LangChain within a week. Okay, so it is an excellent research tool. However, if you want to take it to production, there's a lot of other issues that you have to be content with. One of the biggest issue here is the introduction of Python. I know, in the machine learning space, people love Python. That's my wife is a university professor. She loves Python because it's easy to teach her students and easy to prototype. However, for people of my background, like the IT coming from Java background, Go or Rust, we don't really think too highly about the heaviness of Python because it's a language that is difficult to debug, and it's difficult to build very complex application on top of it. And also because the setup to have a API server and then an orchestration server that sit in front of it, it would necessarily require you to run each of them in different containers, and then you bring a whole different set of scalability problems, right? So what we want to do is that we want to turn Wasm as a developer platform so that we can get rid of all these extra containers and all the extra middleware applications. And so the notion we want is that there shouldn't be excessive work on Python. So so all those tweets on the right side are from, I would say, fairly famous people, right? So from the top is a CTO of OpenAI, and then from bottom is the CTO of Wikimedia, right? That's so it's not just me saying, as experienced developers, that I don't really like Python. There's a lot of people say that, and there's even more people saying that. This is perhaps the most popular article that I wrote on Medium. It has over 100,000 views. Hundreds of comments that people, as you can see, starting a language war is not a great idea. But that's he said that, right? I do believe that's we need to enter a world where strongly typed safe languages like Rust would be able to do become more of the workhorse in large language model applications instead of gluing everything together with Python. And then, when something goes wrong, you have no idea what's wrong. I personally dare not install Python on this machine because I did it a couple of times. There is every single time it's resulting in a deadlock. So for instance, there one time that LangChain requires a certain library, that Fast API requires the exact opposite of that library. So LangChain requires above certain version, Fast API requires underneath. That means there's nothing I can do with this machine anymore. I have to just basically delete everything and restart over again, right? I didn't, because why did I do that? Because inside Docker you can't have access to the GPU. So oftentimes you have to just install it on your bare metal machine, right? So there's lots of complexities that's associated with that. So with the isolation layer that we know as Wasm, I think we can again separate the roles of dev and ops, because I think for a long time that people wanted to combine those two roles. It's called platform engineering or whatever, right? That's developers should write, ops scripts and all that, which is cool. That's. But I think with the emerging new paradigm, I think developers, the developers at least I talk to, do not want to figure out how to install CUDA on a new machine because that is a huge headache. That's so for developers again. We are going back to an old paradigm where developers focus on the logic and the code. So they write code in the language that they're most familiar with, and then compile to Wasm. And that's it. Once you compile to Wasm, you don't need to care about what kind of GPUs you want to run it on, where you want to run it on. You could run it on the Raspberry Pi, or you could run it on a NVIDIA game console, or you could run it on the Mac. We just heard that Apple has released the M4 yesterday, right? So I'm pretty sure M4 support on WasmEdge or on Llama CPP, on all those advanced AI frameworks, gonna come within a month. Mark my words. It's as soon as someone gets their hands on the developer SDK, it will be supported. That's so for developers, there's no need to worry about whether the latest hardware is going to be supported. All they need to know is there is an API called what we call WasmEdge, WebAssembly System Interface Neural Network, right? I use that API to write my applications, and then I compile to Wasm, and then that's it. There's nothing else I need to worry about. Then to install the driver, to install CUDA, to install the Mac driver, to install Metal Framework or LMX on the Mac machine, or CUDA or TensorRT on the NVIDIA machine, or whatever the driver you have on the AMD GPU, would be left to the ops. So the ops guy would figure out how to do that all over again, to become system administrator all over again, because now we are not just having 3 different types of CPUs anymore. We're having hundreds of combinations of accelerators. Essentially now every cloud providers have their own proprietary AI accelerator now, right? So we can have all those things managed by professional teams that are, that manage software and hardware. And then the developer only needs to create an application and write to Wasm, and then the whole application would be able to be copied over, managed by Kubernetes, orchestrated by all those binary artifact systems, and then deployed on the right machines, right? So now I talked about, devs and ops. I say dev is easy. That's you don't need Python. Then is that really? That's people always ask me this question. So so we have some code examples of different application use cases. But then here, those are really the code that's for a simple language completion application that's written in Rust. Okay, so you write in Rust, you compile to Wasm, and the entire thing fits into one PPT slide. Okay. It is actually a lot simpler than writing a similar program in PyTorch. It's on the left-hand side of things, you load the model and put it in memory and give it a couple parameters. On the on the right side of the slide, you create a loop, keep asking what the user wants, and then call a single function called context of compute, and see whether it's gonna give you the result. If there's anything wrong, like out of memory or the prompt is too long, it's gonna give you the errors. But if no error is returned, it's gonna return a byte array that contains the completion that's generated by the large language model, right? And then you decode that model into language and then send it back. So and then it goes on a loop. So it gives you the completion, and then the user asks something else, and then it goes on again. So the entire application code is something that's I don't think it requires people to have deep knowledge about Rust or have deep knowledge about anything. It's in my opinion, maybe I'm wrong, but in my opinion, it is simpler than Python. That's but there's a lot more different examples that in this repository. So in this repository we have the large image models. So so the language model where you can upload an image instead of giving it a piece of language, right? That's it was very interesting. I don't have a demo right here, but if you, it's a lot of people think of this as an OCR, but it's so much more than OCR. So if you upload a picture of the Mona Lisa, but in Lego format, right? It would tell you that this is resembles a famous painting by Leonardo da Vinci, but it's in the modern twist, whatever. So, it really speaks like a human. It is not try to recognize whatever the character that's on the image, right? So we have those applications, that's, so I don't think I have time to show you all that, but, those are we have a whole repository full of examples that you can go and check. And most of those examples today are in Rust, but we are creating JavaScript examples as well. One of the great benefits of Wasm is that it's language agnostic, right? So I believe in another room, Kotlin's lead of Wasm compiler is giving a talk. Languages like Java-like languages like Kotlin and even Python itself can be compiled to Wasm and do things like that, right? So now I want to do another demo. So we have seen a simple API server, and I also said you don't need LangChain or you don't need Llama Index to build the middleware that wraps around it. But is there an example that can show that the whole application, the whole RAG application is being implemented in Rust and then being deployed as a single binary application that goes on to, that can run on my own computer, right? So this is a project, it's called GaiaNet. This is not our project, it's one of our customer projects that built on top of WasmEdge. So what I'm gonna do is that I'm gonna do their demo, so if I go to my workshop page, and so here run RAG demo. The RAG demo, what it does is that, so I'm gonna make sure that I run this on my local machine. Again, it's a one-line installer script. If you say install, this one does ask for your root password because it wants to install its command line tool into the system folder so that you don't have to source the environment in order to, when you install Rust, after you install it, you can't use it in the same terminal, right? So they try to avoid that. So because I cheated, I have the large language model pre-downloaded as well. So what it does is that it installed the whole WasmEdge. So what I primarily want to show you is that WasmEdge is like only 10 gigabytes. It runs on Raspberry Pi and all that. So it's fairly easy to do. Now we can do GaiaNet init. What it does is that now it installs a configuration file which specifies which is the embedding model it needs to use and which is the chat model it needs to use. So the chat model is Phi3, which is the latest model that Microsoft has released in response to Llama 3, right? And then it has an embedding model. But then it spends most of the time importing a vector collection. So what does that mean? Is the vector collection is from a document I created a bunch of vectors. And then I put that into a vector database called Quadrant. That's Qdrant. That is a vector database written in Rust. There's hundreds of vector databases out there. We like that because it's written in Rust, right? That's the only reason we chose it. So we import that into the vector database and created a snapshot out of it. So what is the material that we use to generate those vectors is a tour guide of Paris, France, right? So basically now you see there are 3 elements that go into this node. It has a chat model that is Phi3, and it has an embedding model that is, I think it's fairly commonly used. It's not the highest performance one, but it's very small. So, and then we have a knowledge base. Now, what I can do is I can say GaiaNet start. What I do is that it's gonna start the vector database, start the WasmEdge application server, and then start a domain. I can go to the domain and then come back, but that's, that's typically not good on the conference Wi-Fi because it goes, because the round trip is quite slow. So if I go to the dashboard, it tells you how to use this node as an OpenAI server. So if you have a LangChain application that you use today, you can just change the API endpoints to this one. And then you would be able to use it as a LangChain application. And then you would be able to use it as a backend of the LangChain application. But you can also chat with it. Let me turn on the log so that we can see what's exactly going on with the chatting. So if I, okay, here, sorry. Okay, so you can see the server started and server listened at port 8080. If I ask it the question, say, because I said I have a Paris tool guide, right? Where is Paris? Okay. So what it does is actually it searches the database first, and it comes back with all this context, okay? So it finds different paragraphs of, because it's such a general question, so just to find a bunch of, I would say fairly random paragraph of text that in our introductory text in the guidebook, right? So basically it says, use the following piece of context to answer user question, because it's finding those contexts. So it's put that into the system prompt, and then asks where is Paris, right? Now it's answers. So it's if you ask ChatGPT, it wouldn't give you this level of detail, like its altitude, like it's populated, it says population, or whatever, right? So it's but with this context, the model tries to comprehend what you are giving it, and then come back with the answer, right? So you can go on and ask more questions, but that's the gist of it. So you have a API server that is not only have a large language model, but also have the knowledge base that attached to it, right? So that reminds us what? That reminds us the OpenAI Assistant API, right? So if you build the GPTs in the GPTs store, you import your own documents, and then you have an API where you can access from the outside of the world, where you can build your own application around it. This is exactly the same idea. So so instead of having a Python-based middle layer that sit in front of the large language model, we put all those into the large language model application itself, and then have those applications run as a single application on a single server, right? In this case, it all runs on my machine, on my 16 gigabytes M1 MacBook Pro. So what I'm gonna do is that I'm gonna stop this now. So sometimes it doesn't stop very cleanly, so I'll try. Okay, so yeah, that's let me delete all this and delete this. So go back to my slides. I think I have one more demo, and that will be it. So the next demo I want to show you is the same setup, but I want to change everything. I want to change the Phi 3 model into a Llama 3. I want to change the Paris guidebook into a London guidebook. And I want to ask a bunch of other questions. And so how do I do that? Here, there's, in fact, the only thing you need to do is actually to change the configuration file, which I will show you in a minute, but let me copy this command first. So the configuration file is like this. All right, so it shows you, what's the model to use, what is the prompt, and you can get it very complicated. So we have users that has the prompt that's pages and pages long, right? That's because they want to put their more context into the prompt, right? But that basically configures the whole thing. And but also notice that I did not specify how to search the document, how to chunk the document, because the document was chunked outside of the production environment, which I thought would be the right way to use it, right? Because if you have a large document base, you choose your algorithm how to separate document into segments, and then choose your algorithm how to do the re-ranking and things like that, and then create a snapshot to put into the database. You shouldn't do that on the fly, asking the user to do that, right? I set up this whole system. Now I upload my documents. Now it becomes the system that I can use, right? I thought the right way is really to do that offline, and then have the inference server to have all the data it needs, right? So now, what I'm gonna do is, you can see, this is just one of the simple utilities. It's I run this command, and it changes all those parameters in the configure.json. So now, hopefully, I can do the Guynet start again. So do the Guynet start again. Oh, I shouldn't do this. I'm sorry. because I have an init, so so the new database hasn't taken into effect. Let me try to make sure that I have not missed anything. Okay, so Garnet init. You can see it's now switched to a different large language model and switched to a different embedding model. So the embedding model is not the all-in-one thing. It's nomic embed text or whatever, right? So now it's downloaded the snapshot of the London guidebook and imported that into the Quadrant database. So next, I'm going to start the node. So again, it started node and exposed it on the internet, and but what I'm going to do is also still use the local host. So now it come back, and you can see it tells you, the command you want to use when you use the API, and if you have applications that use OpenAI already, how do you change the parameters to use this one, to use this node, right? If I chat with the node, let me turn on the. And I'm going to ask a different question. I'm not going to ask Paris again because this is the London guidebook, right? What is the population of London? So you see, it goes on to get a bunch of context. It is actually very accurate. If you read this context, it actually come from that guidebook. It's just to get that single paragraph. It talks about, according to the text, the urban area of London has a population of 9 million people in 2011. The wider metropolitan population is 12 to 14 million people. I don't know if it's right or not, but it is what's written in the guidebook. Okay, so so it avoids hallucination and it gives a accurate answer given the context of your guidebook, right? So yeah, so all the demos are successful. That's that's. And you can see, it's generating the tokens on this machine, again, on this machine with Llama 3. It's a fairly capable model. It generating, 23 tokens per second, right? And so let me go on. Okay, so now I have shown you can start a node with your own large language model, or fine-tuned Llama 3 model, or regular Llama 3 model, and with your own knowledge base. And people say, is there many to choose from? Is there a lot of people fine-tuning these models? The answer is resounding yes. I mean, if you look at, I think it's hard to read, but the most important thing is hard to read. So sorry. So I'm going to. It's the models, the numbers that follows models. I'm searching GGUF. It's a specific format of fine-tuned Llama 3 model. And on Hugging Face alone, there's 12,000 of them, okay? So, when Llama 3 first came out like 2 weeks ago, it's widely predicted that by the end of the first weekend, there will be over 10,000 fine-tuned Llama 3 models out there. And they are fine-tuned for all kinds of purposes. There's for different languages, for medical, for different domains, for medical, for counseling and all that. There's one for coding, there's one widely used area of fine-tuning is that to uncensor it. Because all those open source models, because they come from large companies, they also have censorship that's built in. So for instance, to give you an example, there's one of the very famous and high-performance model come from China. It's called E, right? That's it's consistently get one of the top scores. But you can never get it to answer anything about July 4th, 1987. If you ask what is the sum of 1900 plus 89, it would not give you 1989. It would deliberately give you some wrong answer. It was hard-coded not to give that answer in any circumstance, right? So there's a ton of things that people do that's called uncensor, or obviously they have done this to E as well. So after E has passed through that, that's you would be able to easily have it record that the events that happened in Beijing and in that year. So so it has all this knowledge. It's just being aligned very differently. That's so there's many different things that people align those models with their own value systems, right? And also there's another very interesting aspect of it is that people are experimenting with longer context lengths, because one of the forefront innovation, if you look at cloud and and the closed source AI, is that they now have a very large context length where you can fit multiple books in it. You can do character maps and things like that. Can the open models do that? And within 5 days of the Llama 3 release, there was a Llama 3 model fine-tuned with 1 million words of context length. I don't have a computer large enough to fill the 1 million context length, because the memory that's required to run this model increased linearly with the context that you give it, right? So, but I did give it, Romeo and Juliet, and ask who had Romeo killed. It would be able to get all the characters that's that had dueled with him, and list the context of those things. So there's no reason that I would think if I give it Harry Potter, I can probably get a character map of different characters that's in that book as well, right? Of course, this is a very casual study, because I'm pretty sure Romeo and Juliet is in their training material. So I'm going to get one of those English literature class that my son that used to he writes those several page novels and things like that. I'm gonna feed that to the model and ask it to say, can you understand what happened to the character at the end, something like that. But the reason I'm bringing this up is that there's a lot of fine-tuned models for very different purposes. So for languages, for censorship, for domain knowledge, and for the latest advance in, say, the context length and things like that. So that allows us to do a lot more. With the larger context length, it also brings a profound change to the RAG approach, because I know the RAG approach isn't very new. That's people are still talking about it. However, with a very large context window, you don't need to RAG as aggressively. We just talk about LangChain has over 3,000 public-facing APIs, and a lot of them are different algorithms and different fine-tunes. You can incrementally increase the performance of different RAG systems. However, you may not need that, because with a large context length, you can just dump the entire document, you can dump the entire Wikipedia page or the guidebook into the prompt, right? That you can dump the whole chapter instead of trying to find out the minute details of where exactly should I break the sentence, right? So there's lots of things, very exciting things that are going on that you can experiment with open source models that you can never do with closed source models, and so there's a little guide that we have to say, how do you create your own knowledge base? So we wrote, again, coming from us, we wrote a Wasm application in Rust that does very rudimentary, content chunking segmentation and then turning them into vector database and all that. It's my belief that the algorithm to generate those vector databases is going to get simpler over time because of the larger context length that we are getting. Yeah. So yeah, that's I think my time is up. So if you are interested in any of this, again, if you remember anything from this talk, go install LlamaEdge on your own computer and try it. It's a direct replacement of OpenAI, direct replacement of Ollama, and you can do a lot more with it using Rust, using your favorite programming language. And if you have time, go visit our GitHub repository and give it a start. Thank you.
Does anyone have any questions? Yes.
So first of all, that was a fantastic talk. Thank you very much. My question is, what's needed to make a model work with WasmEdge or LlamaEdge? What's needed to get this proper format in? Do you need a model file, or how does it work?
Right. So the question is there a specific model format that works with WasmEdge? So as I mentioned, we are trying to be cross-platform. So we actually have PyTorch drivers and TensorFlow drivers. So in theory, the PyTorch model should just work. However, we don't recommend that because we want, typically we use gguf because llama.cpp is such a amazing framework that it evolves very fast and support all those models in almost real time, right? So we have found that for most use cases, I think the GGUF formatted models on Hugging Face would work very well. However, for the ones that are more, I would say, new or less popular, the PyTorch format should work as well. It may need some work though. We love open source contribution in that area.
Okay, thank you. Maybe a follow-up question. Does it only work for large language models, or could diffusion models work as well?
That's another excellent question. That shows how early this field is. So we currently have a graduate students working on porting the stable diffusion.cpp into a WasmEdge plugin. So it should work soon. That's I would say in a month or two. Which opens up very interesting new use cases. For instance, if you look at the GaiaNet, you could have large language models sitting in front of a stable diffusion model to generate prompt. That's a very common use cases, right? You could also have the large image model or large video model that's sitting behind the stable diffusion model to do things. So we really look forward to adding another dimension of potential combinations to this whole thing. Yeah.
Very nice. Thank you.
Thank you.
Thanks, Michael. So yeah, a commonly cited advantage of running these edge models on your own machine is the privacy and security advantages. I'm curious about the operating system access that is required and your opinions about any potential privacy security issues there.
Right. So the question is, one of the common reasons to run local LLM is for privacy and security. How do we protect that in our environment? So that's why in the first demo that I showed, I turned off Wi-Fi. That's to show that the model can run entirely offline. That's you can put it in a safe room without electronic signal, and you can still run it, right? That's one aspect of it. The second aspect of it is we generally consider Wasm a secure container. That's so at the same level as say a Linux container. That's because it certainly looks this way from the Kubernetes community, because now they are using Kubernetes to drive Linux container and Wasm container. So Wasm provides language protection. So Rust provides static time language protection, and then Wasm provides dynamic language protection. However, the large language model inference itself runs on GPUs. So there are certain sandbox breaking. You have to break out of the sandbox in order to run the large language model. This is just something that has to happen at this moment. But there are new standards that are in the works. For instance, I was just in a call with the people who's working on the WasmEdge Web GPU standard. I believe Web GPU is also soon be supported in the Docker environment as well. So it's an abstraction of the GPU. Also used to be in the browser, but now on the server. So you would have a set of APIs that you would access the GPU from the container environment, which make it a lot safer. So yeah, that's there are lots of more exciting development that's going on in this area.
I'm actually not too familiar with WasmEdge runtime. So I was wondering, you were able to copy that Wasm assembly onto the Linux box and run it without regenerating the target. Is that because that's the capability of the WasmEdge?
It's the capability of Wasm. So so Wasm is a compiler format, right? So you can think of it as a JVM. So it's the Java compiled to the Java bytecode and runs in the JVM. Rust compiled to the Wasm bytecode and runs in Wasm runtime. This Wasm runtime could be embedded in the browser, which is the original use case. So you have a Rust application, a compiled Rust application running inside the browser without breaking the sandbox, right? That's what's the original use case. But you can also take it outside of the browser and put it directly onto the operating system. So that's what WasmEdge does, WasmTime does. So there are a bunch of Wasm runtimes. We call server-side Wasm, So then, just to confuse people even more, is that there's the browser Wasm and the server-side Wasm. So we are very focused on this side of the things, the server side of the things. Yeah.
But you, in your Rust toolchain, you still need to install that WASI, the WASI.
Yes. So
Okay.
the question is, do you need to install anything on the Rust toolchain? Yes. You need to install the WasM32-WASI compiler target. So in the code gen, it's going to generate not the x86 code or the ARM code, but the Wasm code. Then it runs on the Wasm, and the Wasm runtime figures out whether itself is on the x86 or ARM, or it's on NVIDIA, or it's on Apple, right? So the cross-platform compatibility becomes the feature of Wasm instead of the Rust compiler.
Yeah. Okay. All right. Thank you.
Thank you.